Okay, college algebra people, this is section 9.1 and it's solving systems of equations. This will be the first one. This only covers by graphing, solving by graphing. Okay, so I wrote out a lot of words, so if you want to take screenshots of them or whatever you want to do, watch them a couple of times. So when we talk about systems of equations, what we're talking about is two or more equations, and they'll have two or more variables. So if you have two variables like x and y, you need at least two equations to find both of those values. If you have three variables, x, y, and z, then you need at least three equations to solve for all three of those variables. So we're going to do two variables right now, just x and y. And so when we talk about solving system of equations, we're looking for where those two lines cross. And you learned probably back in high school, you can solve them algebraically by elimination or substitution, or solve them graphically. We're going to do the graphically today in this video. We can also use matrices, which is if I have three or more, I almost always use a matrix. And we'll talk about that later because at one point there was an equation, or there was one problem on your final exam that was three equations and three unknowns. So we'll talk about that. It's really super simple if you have your graphing calculator, at least the TI. Remember, I don't know how to use the other ones. All right, so there are three ways that two lines can intersect. There are three ways, or can interact, I should say, because they don't really intersect necessarily. So the first one is they exactly intersect, and they have one common point. Okay, and we usually find that value, and that's called consistent and independent. We don't really care about those words, but that's what they are. They are independent lines, and they are called consistent. If the two lines are parallel, like in the second example, they have 0 points in common. Remember, parallel lines have the same slope. There's no solution at all because they will never cross, and those two lines are called inconsistent, but still independent because they are not the same line. But they are called inconsistent because they don't have an answer. And then sometimes we end up with equations that really are the same line. They're just multiples of each other. And that has an infinite number of solutions. And we'll talk about how we're supposed to write that later. But these two are called consistent and dependent. Dependent because they are the same line. Consistent because they don't have just one answer. Okay, so sometimes you can look at them and tell if you're paying attention. Most of the time we're not paying attention, but you can tell if you are paying attention. So if I look at this first system over here, this one here, I notice, okay, I've got 2x plus y equals 4, 3x minus y equals 5. Those are definitely not the same line. I look at the second example, which is the ones that are parallel, and I notice that even it's not set in y equals, I can say, oh, look at that, 2x plus y, 2x plus y, those are going to be the same slope. I subtract 2x from both sides, my slopes are -2, both of them. So they don't cross at the same place because they have a 4 and a 9, but they are the same slope, so I'm like, oh yeah, paying attention. But again, if we don't pay attention, that's okay too. And then this last one here, notice the 2x and 4x, so the 4 got doubled 2, the 2y was a double of y, and the 8 was a double of 4. So the second equation is a double of the first equation, so really those are the same two lines. And if you were to graph them, you'd end up with that. Okay, so I'm going to show you how to solve by graphing using our calculator because it's pretty simple. I did it before I started the video, and I made a bunch of screenshots with my calculator, and I put them in number order so you can look at them in order. So I have 2x plus y equals 4 and 3x minus y equals 5. So the first thing I have to do if I'm going to use my calculator is solve for y. And I would probably solve for y regardless. So I would subtract 2x from the first one, and I get y equals -2x plus 4. So I put that in the y equals. And so the y equals is Let me highlight that. Here's the y equals, oh, you can't see that. Haha. Here's the y equals button right here. Let me try something else. Here's the y equals button right there. So that's what I would type in, and then I type in my equations. The second equation, I would have subtracted 3x and then divided everybody by -1, so I would have gotten y equals 3x minus 5. So that's my second equation. So I have my first equation in y1 and my second equation in y2. Okay, so now I'm ready to go. Now, if I've been fooling around with my calculator, my window may be kind of funky, so I often use the zoom button. Okay, I hit zoom and then I do number 6 and I do zoom standard. Zoom standard is a 10 by 10 by 10 by 10, so it goes from positive 10 to negative 10 on both x's and y's. So if I'm not sure, if I want to restart everything, I make sure that I start at zoom standard. And then it automatically graphs it for me. Here's the graph. And I notice, hey, these two lines are not the same line. They're not parallel lines, so they're going to have one place where they intersect. So I'm going to want to find that one place where they intersect. So I'm going to go to my friend Calc, which is above Trace. So I do second Calc. And this is the screen that I have when I do second Calc. Sorry, it's not very clear. I want to find the point of intersection. So I'm going to choose number 5. So I hit number 5, and then it asks me for my first curve. Now you'll be able to see your cursor on one of the curves, and all you have to do is hit enter. Okay, so it's already on a first curve. Just hit enter. It does tell you which curve it's on up in the top left corner. Okay, so it's on the first y1, and so I do that. I hit enter. And then it asks me for my second curve. And notice it automatically jumped to y2. And I can see my cursor here at y2. So I just hit enter again. And then it asks me for a guess. So you move your cursor as close to the point of intersection as you can. Looks like a little spider. Start going left or right, depending on where it is already. But I went to the right when I did this, and I put it at the point of intersection. I just hit enter. And then it tells me the magical answer. The intersection is x is 1.8 and y is 0.4. Remember, that's a point. Those are the coordinates of the point. So my final answer is